Good morning, good afternoon, good evening. Okay, so this is for the third objective, which is finding the best sites for biomass plants in your geopolitical zone. Okay, so I've recorded this previously, but it was too long and it was difficult to upload. So I'm going to try to um, run through this. So I've done the analysis. I'm just going to be, describing how I did it instead of doing it. That will make the video too long. So just stay with me. So from the second objective, we should have our biomass raster, which should look something like this. This is for the southwest. I'm using the southwest as sample here. So from this now we have to import our constraint data and the our masking data. So for those two this thing, we're going to use road, slope, and urban max simple. We're going to try to keep this analysis as simple as possible. So here is my road data. You can see it populates the screen, and if you notice what's happening there, you can see it's very dense. My road data for this analysis is very dense. Typically we're supposed to use maybe only tertiary roads or something, but what you can see how dense the road is. So this is going to affect the final results, not negatively or positively, but you should be able to know that okay, if you have a road data that is this dense, it will give you a lot of possible plant locations. So that's my road data. Then the second thing we are going to import is the slope. My slope data, if I still have it. Okay, so yeah, this is my slope data here. Now this is the raw DM file. This is the digital elevation model file. Well, you can't work with that, but just stay with me. Then last but the least, we would have our urban mask file, which is this. Yes, so this is telling us where all the urban centers are in the southwest. Let me remove this road data so you can see those white splotches that you're seeing are urban centers across the southwest. So just for this for the purpose of this exercise, we'll keep it down to these three, and I think that should suffice for an undergraduate research. So after we import this, and yes, I remember that I dropped the scripts to import this exact data set from Google Earth Engine, so you can revert back to that and get that done. So first thing we have to do is to reclassify this data. We cannot use them in this format. Like I said, we cannot use our slope in this format. So the first thing to do for slope is we can't even reclassify slope in this format. We have to go to slope, just take the search bar out like that, search for slope. So now we have this particular slope spatial analyst. So here's another one. So you input your DEM file, which is this slope file for me. Then that's all. Click OK and let it run. So after it runs, it's going to produce this for us, something like this. Exactly. So it's going to produce something like this. So after it produces this particular raster file now is one that we would reclassify. So to reclassify, again, you just click on the search and then you click reclassify. And you search for that. so reclassify. To reclassify, you enter the raster you want to reclassify. In this case, we want to reclassify this slope theory. You have these values, so you see I've already reclassified it, so I don't need to do it. So you just change the values in your own to 1 to 5 as you've seen. So you have to keep this video as short as possible. You do the same thing for your biomass raster, and you do the same thing for your road. Now for road, most of the time ensure that your road data is in projected, in order not to, it has to be in meters. So if you come to this place, you look at this linear unit, it has to be in meter. If it's not in meter, you have to reproject it to meter. And to reproject, you just go back to this search button, you click reproject, and it's quite intuitive on its own. Reproject. Yeah, so you click on this. So then you input the road, and then you select the core. You are using WGS 1984 UTM zone 31. So but for you, if you've not worked with this might not be out here, so you have to go to projected coordinate system. You look for UTM, and then you should have Africa, then you should have that somewhere. It's not coming. Let me confirm. Okay, WGS 1984. Make this thing. Okay, sorry, should be here. 1984, so then you go all the way to 31. This is it. 31 south. Are we in the south or in the north? Let me check. We're in the north. So instead of entering the south, you just go to the north instead. Then you click on one, and then that should convert your road data to meters. Then after you convert it to meter, then you'll be classify it accordingly. So that's the second step. Then we move into the use of raster calculator to perform analysis that will generate the weighted. So you just go to raster calculator. In raster calculator, okay, so yes, raster calculator. Alright, so for me to upload this video easily, I'm going to maybe have to cut this one here and continue in another video. So probably will be in 2 or 3 parts.